We have started the discussion on temperature entropy diagram in the previous sequence of this video. Now, here we are continuing with the same topic. We have drawn this phase change process of H2O in the previous video, where you have um, uh, ice at -5 degree heated to 0 degree C, changing the phase to liquid, that is water, and then you have water heated from 0 degree to 100 degree, changing the state from liquid to vapor. During this process, you have four saturation points, um, such as I can draw those 4 points here. You have one saturation point here, and two here, 3 and 4 on these lines. We have explained what a saturation point is in the previous video. You have a solid saturation at point 1, at which point if you add an infinitesimal amount of heat to the ice at the solid saturation point, it will start to melt and start forming liquid. Uh, Similarly, if you add uh, heat to H2O at the liquid saturation point, which is here, as soon as you add an infinitesimal amount of heat, the temperature of the saturated liquid at 0 degree C will start to rise from 0 to up to 100 degree C. So that is the region where you can add heat so that the temperature will increase. During the phase change process from 1 to 2, the temperature remains the same at 0 degree C. No matter what amount of heat you add, the temperature will remain the same. However, in this region from 2 to 3, as soon as you start adding heat at 2, the temperature will start to rise from 0 to 1, 2, 3 up to 100 degrees C. Now, similar to the condition from 1 to 2, during 3 to 4, as you add heat to the saturated liquid at 3, the phase change process will start. However, the temperature of this process will remain at 100 degrees C. There will be no increase of temperature until the whole of liquid is converted to vapor at, or saturated vapor at point 4 here. Now, as the liquid saturation is that point from where, as soon as you start to add heat to the saturated liquid, it will start formation of vapor. So this region is the region where H2O can coexist as liquid and vapor. So this is a region where at 100 degrees C at 1 atmosphere, 1 atmospheric pressure, H2O can coexist as liquid and vapor, and at 0 degrees C, H2O at 1 atmospheric pressure can coexist as solid and liquid. Now, at 4, you have saturated vapor. All of the liquid you have, or all of the water you have, has now been transferred to the vapor format or vapor state of the matter, and you have a saturated vapor here. Now, if you remove heat from saturated vapor, it will start to condense and form liquid. And if you add heat to saturated vapor, it will start increase the temperature. So as soon as you add a heat to saturated vapor at point 4, the temperature will start to rise. So you have 101, and you can increase as much as you want the temperature of vapor. And in this region, the vapor is called superheated steam. So anywhere above 100 degrees C at 1 atmosphere, the steam is called superheated. you have a liquid vapor mixture here at 100 degrees C and 1 atmosphere. You have a liquid region here, only liquid, and you have a solid liquid mixture from 1 to 2, and you have a solid region below 0 degrees C. So any temperature below 0 at 1 atmosphere is solid. Solid to liquid at 0 degrees C during the phase change process, and a completely liquid phase from 0 to 100 degrees C at 1 atmosphere, and the liquid vapor region at 100 degrees C during the phase change process, and above 100 degrees C you have superheated steam. Now, what happens if you repeat the process at 2 atmosphere? You will be able to generate a similar graph. I'm just drawing a graph here. You have a, a solid region, and then a solid and liquid region, and then you will have a completely liquid region from this is it's a bit difficult to, and then you will have a liquid plus vapor region, and then you will have a vapor region only. So you can form as many graphs as you want at different pressure conditions, but this will be the general form of the phase change process of H2O at a specific pressure and different temperatures. Now, if you join these saturation points, you can draw a line which will eventually form the graph that we intend to create at the end of this video. So, for example, if you join all these points at 1, say you join these, and then you join the 2s, and then you join the 3s, and then you join the 4s, you will be able to create a graph which will look like this. You will have 2 lines here, and then you will have like this, which is the temperature entropy diagram of water. I will explain further about this graph in the next video, so do keep watching. It is important to understand either a temperature entropy or a temperature enthalpy or a pressure enthalpy or an enthalpy entropy chart if you intend to study more about the thermodynamic process of phase change. However, I'm not scaremongering you by giving 4 charts. As soon as you understand completely one of these, it will be dead easy to understand any of the other. So do keep watching. Do keep an eye for the next video in this sequence. Thank you for watching. Thanks very much. Do keep watching the next video. Thank you.